All right, so we had a few examples, and these are not all of them. Okay, so some keywords that are missing here would be, for example, there is no maximum, but there's minimum here, right? At least. There's also at most, up to, right? So all of these are keywords that indicate an inequality, right? That it's not exact, but it's like you can have up to that much, okay? So now we're going to write down steps here. Steps that are generally involved in word problems. If you see WP from now on, that's word problems, okay? That way I don't need to always, like when I label my entries on Google Classroom, you know. Okay. So first, you should introduce your variables. Right? X would be the first variable in problem. And then Y would be the second variable in problem. It could be large t-shirts, small t-shirts, or pants and shirts, and whatever comes up, right? Second step, state the implicit constraint. And sometimes we call it restriction. Since we only have positive values, we state x is greater than 0, y is greater than 0, greater than or equal to 0, or you can write it in one shot like this. And that's because we are stuck to quadrant 1, right? Okay, number 3. Write the inequalities or inequalities. Example, x plus y is less than or equal to 20, 2x plus 3y is greater than or equal to 40, and there could be 1, 2, maximum 3. Sometimes 4, but those will be rare. Graph this system. But only focusing on first quadrant. Fifth step, state the coordinates of any corner points. Corner point or corner points. Right. Both the actual and rounded coordinate. And by this I mean if it's a discrete set of data, then you will have to round. But I want you to write both the actual and the rounded coordinate side by side. So these are the steps in general that you will have to follow, okay? It's kind of going to flow this way anyways. And we're going to really focus on the corner points because they are ultimately going to give us the solution to our problem, okay? Oh, what's that? Rounded coordinate. Yeah. Does it, oh, it kind of looks like it's making contact there. Okay, I didn't even notice that people were chatting there. They have to like do a better job at notifying me. Okay, you figured it out though, good. Okay, so now we're gonna actually go through a word problem and see how this is done, following these steps. We're good writing this down? Yeah. All right, example. A certain manufacturer makes scarves and toques. It takes 15 minutes to produce a scarf and 10 minutes to make a toque. The maximum production time is 2 hours. Create a graph showing all possible combinations. use my highlighter. So the first thing you want to do is identify, right? I'm going to put the step number down here, but you don't have to do this when you solve on a test or whatever. It's just for you to guide, right? So we will basically let x be the number of scarves, right? So you should have usually the first sentence gives it away. Like what are the two variables going to be? And so we know scarves and toques are talked about. So don't just put down scarves. X is the number of scarves that are being produced. And we'll let Y be the number of toques being produced. So that's what I mean by identify your variables. Secondly, we're going to just say that x and y, this is our implicit constraint, okay, is greater than 0. We're making sure that's stated. And if you look at your data, what kind of data is this between continuous and discrete? What would you say? It's discrete because it's number of, like you need a whole number, right? So we'll just make a note here. This is discrete. So implicit constraint, and I just put down what kind of data we're dealing with here. Number 3, we're going to come up with our system of inequalities. Okay. So first of all, you always have to look for the restriction, right? In this case, the only restriction that is mentioned here is that there's a restriction on the time, right? The maximum production time is 2 hours. Okay. And they have to give you, if there's a restriction on time, they also have to give you how long it would take to produce each one of them to begin with, right? So we'll say that if it takes 15 minutes to produce a scarf, right, and it takes 10 minutes to produce a toque, that would have to be less than or equal to, and we won't put down 2 hours. What would we have to put down? Because this is minutes, 2 hours would have 120 minutes, right? Just make a note here, 2 hours, it's going to be 120 minutes. We need everything to be in the same units, right? So if they do grams and kilograms, make sure everything is in one unit, right? So maximum of 2 hours combined, right? So they could choose to make, 0 of one and just focus on the other product, on toques. It doesn't matter, but the combination of the two can be a maximum of 120, okay? All right, so now we'll just start graphing this. So this is the only inequality, unless you can see something else, but don't make one up that isn't there. I see that a lot. Like, oh, I have to have another one, like somehow. It's like, well, what else is there? They're not saying that you can, like the sum or the combination of toques and scarves has to be, at least 20. They're not saying any of that. They're not specifying that there's a restriction on just toques or just scarves, right? Like they could have said because the demand is higher for scarves, you need to make at least 10 scarves. That's specifically for scarves, not toques. So we'll talk about how that changes as we go along. But for now, this is the only restriction given. So we're going to do this. Just like before, once you have that, the rest is basically the same thing as we've been doing so far. Find the x and the y-intercept. 15x equals to 120. Divide both sides by 15. X is equal to 8. So we have 8, 0 here. Y-intercept is 10. Y is equal to 120. Divide both sides by 10. Y is equal to 12, 0, 12. Okay. Grab a ruler. Most of you did pretty good. Some of you gave me a little bit of a sloppy graph right on the AC, so make sure you use a ruler. So we're going to graph it right here. Doesn't have to be taking up a whole lot of room. Do yourselves a favor. Before you graph, a lot of us just want to jump into the graph. What is X again? Number of scarves. Get it ready, right? Because otherwise you'll forget it later. And this is number of toques. You have to have the units in there too, right? And number of does the trick. Then you have to decide on a scale. And it's like when you have more than one inequality, you want to look at all of the intercepts. Right now, we only have to worry about the x and the y-intercept of that one inequality. So if you go up to 10 and then 12 here, we're fine. So 2, 4, 6, 8, 10, 12. I'll go a little further, 14 probably, and then 2, 4, 6, 8, 10, 12, 14. So I went 14 each way. I'm just going to label every other one. Saves you a little bit of time. But you need a guide, right? 8 zeros right here. By the way, most of these are going to be solid lines when it's a word problem. 0, 12 is here. And I kind of skipped to the graphing part. I shouldn't have done that. Because we need to figure out the shading and rewrite and all of that stuff. Finish the graph, and then we're going to go back to here and do what we always have been doing, okay? Right from the beginning, which is rewrite it and then tell me where you're going to shade and whether or not it's solid. So here we go. 10y is less than or equal to 15 comes over the other side. Divide everything by 10. Do not flip the sign because you're dividing by a positive. So that's negative 15 over 10x plus 12. This is 3 over 2 if you want to reduce that. Be my guest. Nothing wrong with that. So this is solid. True is below. We're going to shade above. Okay? So you take your pencil and make sure it's visible. Before I shade in, I'm going to just make sure this fits the right label first. Label your inequality, and then you can kind of shade around it. That's what I do. Make sure you label your solution region. And this is where practice will show on a test. If you've practiced this, you will know all these things, okay? So label, units as well. Scale, I label the inequality, I shade appropriately, I tell where the solution is. So anything inside this triangle, right? Any point inside the solution region is a combination that can be produced. What are my corner points here? What do you think? Because there isn't another line, right? There's only one. And this is where it changes, folks. This is where the intercepts are actually part of the corner points. Because your solution region is surrounded by, right, 3 sides, okay? So it would be 0, 0, which is the origin. It'd be 0, 12, and it would be 8, 0, all of which you have already found up there during your work, right? What does this mean? This is basically saying making or make none, right? You're shut down, you're not making any. You're making 0, 0 scarves, 0 tubes. This is saying making 0 scarves and 12 tubes. Sorry, my spacing was off here. Right? 0 scarves, 12 tubes, because remember, this is scarves, this is tubes. This is making 8 scarves and 0 tubes. My bad. Sorry. And so that's what you need to understand. So any combination, like making 4 of each, would still work. Making 6 scarves and maybe 2 tubes would also work, right? So any combination inside here is possible. But we're focusing on the corner points, and you will see why in a bit. Okay. Right. Let's do another one. This one will have more than one inequality. Oh, it's almost 2.